Alright, more assorted problems. We've got FeOH3. If I draw a picture of that, it's going to look like Fe, and you can see we've got a 3 on the outside of parentheses with OH, so that's going to be 3 OHs. Since this is the polyatomic ion, we'll look on the polyatomic ion sheet. We see OH has a -1 charge. That means we've got a total charge of -3, which makes for a total charge of +3 on the other side, meaning the ion is going to have a +3 charge as well. So the name of this is going to be iron 3 hydroxide. And iron, if we look at the periodic chart, you'll see that it is a type 2 cation, so that's why we have to include the 3 in the name, because Fe could be 2 or 3, and we need to know which one it is from the name, and that's how we would know. Alright, let's look at the next one. We've got BaC2H3O22. So if I drew a picture of that, it would look like this. Ba and C2H3O2, and we've got 2 of those because we've got the 2 on the outside of the parentheses. This is a polyatomic ion, and I can find it over here. There it is. It's got a -1 charge. Total -2. Total +2, which makes the Ba have a +2 charge. So we're looking at barium acetate. Now there's no need to put a number here, because if we look at the periodic chart, you can see barium is in group 2, which means it's always going to have a +2 charge, so there's no need to put a 2 in here. So I'll go back to the polyatomic ion sheet here, and just to point out what the ions are for these answers, we've got Fe3+ for this one and OH-. Remember, we're just picking out one of each of these so we can get the name. So you get the iron 3 and you've got the hydroxide. Likewise here you've got the barium, and then we've got the acetate ion, so it's barium acetate, and those are the 2 ions that would be the answers for these as well. Alright, so looking at the next one, we've got calcium and sulfur. So calcium sulfide is what it's going to be. We've got S2- because S is in group 6, -2, +2, and then 2+. That's for the calcium. And the name would be calcium sulfide. Calcium is in group 2, so it always has a +2 charge, which means we don't have to put a 2 here in the name. Alright, so looking at the next one, Sb2S5. I draw a picture of that, and there'd be 2 Sb's, and there'd be 5 S's. And each of those has a -2 charge. So the total negative charge here is -10, which means the total positive charge to match that must be +10. And each of those antimonies then has to be 5+ to give me +10 down here. So the 2 ions that I'll be using to get the name will be S2- and Sb5+, and the name here on the compound would be antimony 5 sulfide. So the antimony 5 comes from the 5+ charge on one of the antimonies here. So this 5 here represents the charge on each antimony in the compound. So that's how I get that name, and these would be the 2 ions you would use to get the answer. Alright, let's continue on with this. We've got one more to do. And we're looking at HBr acid. I draw a picture of HBr acid. It will be H and Br. Br has a negative charge, H has a 1+ charge, and the name of this would be hydrobromic acid. Now the H+ is the acid part. The hydro here is telling us that this is a single element as opposed to being a polyatomic ion. And that's how we're getting the name hydrobromic acid, bromine and an ic at the end for a single element.